understand factors that regulate populations of herbivorous insects and slugs. The long-term goal of his research? Oh, okay, great. I butchered it enough, he's kicking me off stage.
All right, thank you. Yeah, I don't need to do that introduction. I'll just say I'm an entomologist. I'm from Penn State. I value being in Indiana. I did my graduate work at University of Illinois. So coming back to the Midwest is great. I feel like a little bit of a poser, but we'll get through this together. Because Pennsylvania agriculture is a little bit smaller scale than what you guys got here, but I hope some of the principles that we've learned in Pennsylvania can translate out here. Okay. So I understand it's getting late in the day. You let your mind wander. These are the 4 things I'd like you to remember. So if you don't remember anything else, these are them. So no-till. So I'm a no-till guy. I'll go into no-till in detail. If you're not doing no-till, I hope maybe this can push you in that direction. So no-till of cover crops builds diversity and can improve pest control. That diversity actually improves your crop production, but integrated pest management is kind of the key to protecting that diversity. And pairing IPM with cover crops makes them more useful. Okay? Okay. So the overall, kind of overarching theory today is integrated pest management. I hope that you've been exposed to this before. I understand Christian Krupke talked at this meeting last year. Christian's a good friend of mine. When we talk about integrated pest management, I'm usually on the East Coast, he's in the Midwest, doing the same thing. So this is just using a combination of tactics to control any pest problem you have. Just for a little bit of history, this was introduced in 1959 by some entomologists out in California. The main goal was to reduce calendar sprays of insecticides. So rather than spraying every June 1st, every June 15th, and so on, we're going to put an insecticide out only when it pays, only when it makes economic sense. By doing that, we're going to actually protect natural enemies, so allies in pest control that can then take care of the insect pests that you have. So IPM ensures profitability. We're only going to use an insecticide when we know that it pays. And there's just three key principles. One, and the first one is tough, particularly in corn, is avoid preventative insecticides. Number 2 is just scout to know what's in your field. And 3, if you find a pest population in your field, let's put it out an insecticide if that population exceeds what's called the economic threshold. Economic thresholds are published. If you need them in Pennsylvania, you can call me. If you need them in Indiana, you can call Christian. Right? Okay, so a lot of the topics today that have been covered are focused on soil quality and soil health. If you're in Pennsylvania, you want to grow soil health, you're going to do 3 things. You're going to no-till, you're going to have a nice crop rotation, and you're going to use cover crops. So doing that builds life in your soil. Right? And what the other 2 speakers talked about was mostly microbial life. A few mentions of arthropods were made. But in my mind, as an entomologist, we want to build all life, not just microbial life. So we want earthworms. A lot of farmers are super proud of their earthworm populations. If you farm this way, you'll have more earthworms than you can count, which is great. But you'll also grow arthropod populations. So arthropods include insects and spiders. Most of those are good things. So if you want to protect that soil quality, protect those populations, those communities that you can grow, then integrated pest management becomes relevant. So this means valuing the life in your field and just don't use insecticides blindly. Okay? Insecticides kill a lot of things. So we want to know if pests are problematic and then use them if it makes sense. This way we can protect those arthropods, both natural enemies and decomposers, which can help in your productivity. Okay? We want to use insecticides as a last resort. And this runs counter to what your seed dealer tells you, and it might run counter to what your chemical rep tells you. Okay? I recognize that. And some of those folks use my name in vain. That's all. Okay, but let me acknowledge from the start that Pennsylvania is different than Indiana. 14% of Pennsylvania is dedicated to agriculture. Okay? Most of this is not. Most of our agriculture is down here in the southeastern part of the state. I'm from the State College area, appropriately named in Center County. Right? And that's where we have what we call the ridge and valley system. So you see these things, these little bumps or hills, and between those valleys, that's where our farmland is. Right? So we tend to farm in the valleys in the center part of the state. In the southeastern, it's more flat like it is out here. Right? So the nice thing about these farms is we have these kind of wildlands in proximity to our growing areas, and that contributes. I'm going to fall over this every time. I'll figure it out. It's pretty. It's a pretty place to live. Pennsylvania is also a no-till state. These data are dated, but they're from the 2012 Ag Census. And they're comparing the amount of tilled land in the denominator to the numerator, which is the amount of no-till land. So Pennsylvania, you're getting above 2 to a 3. Type, the dark blue ones. You know, a lot of the mid-Atlantic states are all no-till to help protect the Chesapeake Bay. Kentucky, Tennessee are protecting these waterways, right? And then some places in the Midwest don't get enough rain, they have to be no-till. Indiana's a little bit different, a little bit less no-till, but I talked to some folks today that are doing no-till, and that's great. We do no-till on about 75%, 3/4 of our acres, okay? And that's not very much acres when you compare it to Indiana, but we have about 1.5 million acres of corn and soybeans. That might be one county around here, I don't know. But no-till has obvious benefits, right? You decrease labor, you don't need as much time in the cab, you decrease fuel use, you don't need as much fuel to run across the fields. But in key years, we're maintaining soil, less erosion, and we're infiltrating water better. So that's great about no-till. We do no-till to prevent this, right? So here's a gentleman that tilled his field, and we have some slopes in Pennsylvania. This gentleman tilled his field, and then it rained, and most of his topsoil is on the road, okay? It's running to the local stream, and when it runs to the local stream, then you get that problem, okay? This might not look familiar to you right away, but let me orient you here. So this is the mid-Atlantic United States. Here's the end of New Jersey. This is Cape May. We don't need to insult New Jersey just because we said New Jersey, but you can do that if you want. This is Philadelphia up here. This is the Chesapeake Bay. That Chesapeake Bay, this is in 2011 after Tropical Storm Lee came through and dumped a record amount of rain in the Atlantic states and washed away a lot of our topsoil. So that's topsoil in the Chesapeake Bay. Most of it coming from the Susquehanna River, which drains the middle of Pennsylvania where I live. Okay? So on a crazy rain day like this, we can't stop that type of siltation. But on a daily basis, this is what no-till is trying to avoid. So that's why we're doing it. So I trust the folks that are doing no-till in this part of the world have similar motivations with all the lakes and streams and whatnot nearby. So this is a bad thing. We're trying to avoid that on a daily basis. But everyone will acknowledge that no-till makes conservation possible. Okay? Immediately by stopping tillage, you're going to hold on to your soil better, you're going to get better water infiltration, and you're going to get more advantages than you get disadvantages. Right? So you might see this as trouble. Right? Here's a close-up of a soybean field, a lot of residue there. I see that as potential. As an entomologist, I see that as habitat. It's great habitat for natural enemies. And we know from our research that you got more natural enemies, beneficial insects, in no-till fields than you have in tilled fields. Then if you can put cover crops in your system on top of that no-till, you have the potential to grow this localized food web. This localized food web, of course, have plants at the base. Those plants at the base are going to be protected by all this dog-eat-dog stuff going on above them, right? And that's a great thing. So that's what our research in Pennsylvania is showing. The more of that diversity you have, the more things that are eating each other, the better off your crop plants are, without insecticides as much. Okay? And the drivers of this are called ground beetles. Ground beetles are common in your fields. You can make them more common and your pest populations go down. One of the great things about ground beetles is that the adult and the larvae are both predaceous. So on the upper left, we have a larva of a ground beetle. Lower right, we have an adult. This is one particular species that's just under an inch long as an adult. The larvae are subterranean. They burrow through the soil. Anything they run into, they try to eat. They have these big mandibles, sickle-shaped mandibles up front. These guys have the same. Okay? If there's one of these guys the size of a dog in downtown Syracuse, the cops would be called. Right? But because it's just in your field, it's less than an inch long, running around, you kind of ignore it. They're often out at night, so you don't see them. But the great thing about them, particularly in a no-till system, is they're eating the pests that are more problematic in no-till. It's not that pests are more problematic in no-till, it's just a different suite of them. Okay? So black cutworm, true armyworm, wireworm, and slugs are the main ones that I get called out, with slugs in capital letters and underlined. I'll get into slugs in a bit. But those are the main things we worry about. These guys eat slugs for lunch, dinner, and breakfast. works, just for dramatic effect. Apologize. But that really is why I became an entomologist. I love watching things eat other things. I've only been able to go to Africa once and see that in person. That's pretty great, but it's kind of inconvenient, right? I can do this in my backyard. Okay, so ground beetles and other animals eat pests that are in your crop fields if you let them do that. Let's just take a quick diversion to make to emphasize a principle. Maybe some of you folks are hunters. Hunting's a big deal in central Pennsylvania. The fact that I grew up in Connecticut and don't hunt is like a stain on my family for the rest of my days. My kids don't hunt. But all my neighbors do, and they're blown away that I don't know what they're talking about. But anyway, if you are a hunter and you go out to the woods, you want to see this. Maybe you prefer to see a buck or two, but let's imagine you see 2 does. That's great. What I heard talking to my neighbors in Pennsylvania, they go out in their woods, they're all ready to hunt, they're out there at 4 in the morning. They don't see this, but they see this. Right? They don't see any deer, but they see clear evidence that the deer have been around. What's the evidence in that picture that deer have been around? There ain't no understory. Thank you very much, sir. Right? There's nothing regrowing here. Right? There's not even a sprig. There's not a maple tree, a little sprig of maple coming up. So we know they've been around. Right? Thank you for the response there. So we know this. From this, we know that deer strongly influence forest regrowth. If you can exclude deer, eastern forests would come back a whole lot faster than they currently are. And we know this in part because of logic, but also because of experiments like this that are run by various universities. Here's a deer fence erected in the forest. Deer have access to this side of the fence. They don't have access to that side of the fence. Where is the forest coming back? Right? Where deer are excluded. A lot of these things are mayaples, which aren't really going to grow into maple trees, or oak trees, but they're scattered in there in the understory. Okay, so we know that deer are excluding these types of plants because they're so abundant in the eastern field. We can take advantage of this principle and think about predation. If you've ever been to northern Wisconsin, here's a map of northern Wisconsin, and believe it or not, they still have wolves up there. Right? And the wolves are residents, and the packs of wolves roam around, right? They're called packs of wolves, they roam. And this map, published in 2013, shows different residence times of wolf packs in that part of the state of Wisconsin. Okay? So the darker the color, wolves have been around for almost 10 years or so. Okay? The lighter the color, wolves haven't been around. Right? So these white areas, wolves aren't resident there. I'm not advocating for wolves to be reintroduced anywhere, it's just an example. So wolves are around, right? They're looking for food. Oftentimes they want to eat deer, and the deer run scared. Right? So where wolves have been around longer, forest regrowth is happening faster. So this is a picture that I borrowed from the publication, so it's difficult to see, particularly in this light, but it's a similar picture to what I already showed you. There's not very much growing here, regrowing in terms of forest regrowth. Whereas wolves, where they've been in residence longer, deer are running scared, and the forest is regrowing faster. There's more diversity there. Okay? And I'm telling you something you already know. Wolves scare things. If I lived in an area with wolves, I'd be a little bit hesitant about staying in the woods too far after dark, right? But we know then that predators like these can protect plant growth. The forest is coming back better where wolves are more abundant. But it would be wonderful if we could take advantage of this in agriculture. Like, we don't want wolves in our fields, but maybe we can have things that do the same thing as wolves. If they did, then we would have this pattern. And this pattern is from our research. The horizontal axis is a predator population. The vertical axis is the proportion of plants receiving damage. As that predator population goes up, the proportion of plants receiving damage goes down, right? So when we're at this sweet spot here, a bunch of predators, we have very little feeding damage on your corn plants. Right? So these data are from a 6-year corn experiment in Pennsylvania. The more predators we have, the less predation, sorry, the more predation we get, the less damage we cause. Okay, so that's great. Okay, so that's what predators can do if we let them. Let's think about insecticides. Insecticides, whether you're putting them on the leaf, in the furrow, or you're buying them on the seed, have been overused. Insecticides became widely used in the United States just after World War II. Every year since World War II, the amount of insecticides applied to America's croplands has gone up. Right? So that's true from 1945 to 1946, that's true from 1996 to 1997, and that's true from 2023 to 2024. Every year, the amount of insecticides applied to our lands goes up. It's amazing. In part because companies market these things. Right? You're not just some empty vessel accepting, just making your own thoughts. You're influenced by advertising. Here's an advertisement from a while ago. Right? This is when DDT was a thing, right? Back in the 50s. There is a singing potato. Why wouldn't you use DDT if you have a potato singing about it and how wonderful it is? Look at that housewife. I don't know what the perfect woman looks like, but this person thinks that that might be the perfect one. Right? And she's even singing about DDT being fake. Right? So we can laugh at this. This was DDT. DDT's banned here. It's not banned elsewhere. We still make it. Sell it elsewhere. Oh, just for saying, this is from the Pennsylvania Salt Company, Philadelphia, Pennsylvania. So close to home. These advertisements are still relevant. They're still happening today. I'm not going to name this company, but they make a particular seed treatment that goes on your corn seed. And they're trying to scare you into using it with this advertisement. Has anyone in this classroom taken an entomology course? Oh, whole bunch of folks. Okay, black hat back there. What is this animal? Or anybody. You can have your neighbor in the blue shirt. What type of animal is this? I love them. I like it because of the nose. Right, let's go with aphid though. Aphids, right? Aphids are what type of animal? How do they feed? Piercing, sucking. You guys, great, excellent. Piercing, sucking mouthpart. So this is their mouthpart. But what does this animal have?
Teeth.
Teeth! It has 2 mouths. They photoshopped a mouth. In addition to its primary mouth, it has a secondary mouth with teeth. If you learn nothing today from the speakers, learn that aphids don't have teeth. Aphids don't have mouths that look like that. And inside those secondary mouths, they don't have craggly teeth. Why would you put a nice set of shiny teeth when you can put craggly teeth? Right? Because that's going to scare you. Like, you're going to get a little bit uncomfortable. I don't want this monster. They say, the seed treatment, that little monster is feared. No, but they're really trying to scare you into using this, because that thing has craggly teeth. Right? So this is clearly dishonest, but you look at it and you're like, oh, that's interesting, move on. An entomologist stops and says, what is that thing? How come it has 2 mouths? Funny as hell. Okay, so insecticides tend to be overused. I would encourage you to think about using integrated pest management to govern your insecticide use. Because if we don't use them well, we can decrease the number of good insects out there, actually make pest populations worse. Then there's a whole raft of environmental concerns. The number of cases of insecticides in water is too great to count. If we went out and sampled this lake here today, we'd find insecticides in there. And as someone who loves the environment, I would love to try to reduce the amount of insecticides in water. Here's just some evidence that insecticide use is intensifying. This is the amount of bifenthrin. Bifenthrin is the active ingredient in capture LFR, bifenture. There's tons of formulations of bifenthrin. This is the amount used in the country over time, starting in 1992 to 2017, that continual uptick. Sure, there's some decreases for this particular active ingredient, but overall these insecticides are going up. Corn and soybeans are in green and yellow. Okay, so we use a lot of bifenthrin in soybean and corn production. Most of this use is not based on need, it is based on either advertising or helping you sleep better at night. Okay? It's a little bit disconcerting. If you want to see what this looks like in map form, these maps are available from the U.S. Geological Survey. This is the amount of bifenthrin used in 1999. We're in Indiana, so you can focus on that. Watch the color returns. 2017. 1999, 2017. Okay? Your state turns red. Pennsylvania doesn't do much better. I use these maps in Pennsylvania too. Right? This is just one active ingredient. This isn't Warrior, which is the most popular insecticide for broadcast applications by my measure. By Fenton, it's fairly popular though. This is the amount of clothianidin, one of the active ingredients coated on seeds. It's that poncho stuff we just made fun of with a two-mouthed aphid. This is the amount of clothianidin used in the country over time, starting really in 2004, ending in 2014. That increase is not based on a new challenge. That increase is based on marketing. Okay? The insects that could be controlled here and the insects that can be controlled here are about the same. So this is based on marketing and big companies deciding to put it on the seed and then you guys buying it, whether you're aware of it or not. This decrease from 2015 onward isn't because they stopped using it, it's because the data stopped being collected. This is what the adoption rate looks like. These are data from former grad student of mine. This is the amount of neonics used in the country over time. Corn and soybeans are in red and in orange. Our data also stopped in 2014 because they stopped giving us those data. That adoption, like how steep that adoption curve is. Again, it has nothing to do with a new pest being on the landscape. Executives at big companies decided to put this on seed. They sold it to you, everybody's buying it. And then they work to convince you that it's necessary. So if I suggest you grow an untreated seed, you can say, John, you're an idiot. You can do that in Pennsylvania, you can't do that here. Well, I'm not sure that's true. So that's marketing. This is the amount of clothianidin in the country in 2003, which is to say none. 2011, 2014, where the data stopped. Okay? This is in pounds per square mile, when the amount being put on your seed is in milligrams per seed. It's a remarkable increase. So these things that are coated on your seed, I'm sure you're familiar with them, they're the neonics insecticides. Right? They can protect yield. The only way they can protect yield if there's an insect to control. And the insects that are being targeted aren't very common, so it's unlikely to happen. They're water soluble. That water solubility is great. They're put on a seed, you plant that seed into the soil, that capillary action pulls that insecticide out into the soil, and then that plant starts to grow and it runs systemically in the vasculature of the plant. So anything that bites, say, one of these leaves, is going to get a dose of the insecticide. It's just a question of whether they're susceptible to the insecticide and if they get a dose high enough to them. Right? It's the most toxic insecticides that have ever been developed. Okay? And if we looked at the label on corn and soybeans, this is what those neonicotinoids on the seeds can control. The aphids, even the two-mouthed aphids, can't be controlled well. So the ones in parentheses aren't controlled well by the seed-applied insecticides because they arrive on the scene too late, well after planting. So the concentrations in the plants are very low. So aphids aren't being controlled, whether it's corn leaf aphid or soybean aphid. The ones that are underlined here are where the insecticides do particularly well. Okay? Seed corn maggot wireworm, bean leaf beetle, seed corn maggot wireworm. Unfortunately, seed corn maggot wireworm tend to be uncommon in no-till fields in Pennsylvania. I would be surprised if they weren't uncommon here. So when you plant these seeds, very little that goes up into the plant. So we plant a treated soybean seed. Most of it, because it's water soluble, washes out of the seeds, goes into the local waterways, goes into neighboring plantings. Some of it goes into the soil and provides some protection against root feeding pests for about a maximum of 3 weeks. But most of it isn't going into the plant. About 98% of it stays in the soil. Doesn't help with crop protection. In my hands, this is what you get. You can say, well, you're an entomologist, not a farmer, you can't grow anything. Fair. Farm staff planted this though. Yield on the vertical axis for soybeans on the left, soybeans on the left, corn on the right. Same exact yield, whether you're using this treated seed or untreated seed. And this is just presence or absence of the insecticide. I'm not talking about the fungicidal portion of that seed treatment, so we're just talking about the insecticide. You say, all right, John, you're full of crap, you're an entomologist from Pennsylvania, fine. If you've ever been to this part of Ontario, beautiful farm country, flat as a pancake, corn, soybeans, no-till cover crops. Very much like Pennsylvania. Folks there published a wonderful paper where they did a 4-year experiment corn and soy fields where they compared the insecticides on they compared seed treatments of just the fungicide to a fungicide plus the neonic insecticides. And here are some of those data here. Again, these are some scientists at the University of Guelph. So what we have in this column is the results when we just have a fungicide on the seed. Here's when we have a neonicotinoid plus the fungicide. So the only difference is there's an insecticide in the right-hand column. This is corn, over 145 farms. So it's not just me on my research farm. They evaluate stand establishment, below ground injury, above ground injury, and yield. And these numbers are virtually the same. There's no statistical difference with them. So there's no advantage to having the insecticide in the mix. So this is at the V emergence to the V1 stage of corn. And they also quantified the insect pest populations. So here's wireworms, white grubs. Again, insecticides in this column, no insecticide in this column. Numbers are the same. It's not because the insecticide doesn't kill insects, it's because the insects are rare. So these insecticides on your seeds aren't providing much benefit. But they are providing a cost. Yeah, sorry about the fives. That tends to happen when I go from my computer to one of these guys. That's fine. This is what I call a spider plot. A spider plot just shows multiple axes and allows us to assess many things at once. So each of these axes is a function that we want from soil. Okay? We want more endophytes colonizing our plants. As endophytes are in the soil, and they go into the plants. We want more mycorrhizal fungi. We want more decomposers. We want more predators, and kind of so on. So the farther out on each of the axes is where we want to be. The green line shows where we have no insecticides in this system. So the green polygon there has the biggest area. As we add insecticide and increase the amount being applied from blue to yellow to red, the size of the polygon shrinks so that the red polygon is the smallest. Okay? So that means the insecticides are limiting the function of that soil. Previous speakers both mentioned that if we put pesticides in the soil, function restricts or is limited. That's exactly what we're seeing here. These data are from a colleague at Cornell University in New York. These data are from a turf system, but there's no reason not to believe the same thing isn't happening in corn or soy. Okay? So the more insecticides you put in, the other things are kind of turning off. They reduce. Right? So insecticides are limiting function in the soil. This might not be a problem just on a daily basis if you don't have pests, but if you live in Pennsylvania and you have slugs, it's a big deal. Right? I heard just chit-chatting with some of you guys today that some of you guys have slug challenges. Slugs are the most important pest in Pennsylvania that I get phone calls about. The most important pest that I don't get phone calls about are deer and then groundhogs. But in terms of things without spines, they're slugs. Here are slugs on the front of a hay mower. Isn't that amazing? So Roger, here's your idea, harvesting those. You can use those as Pennsylvania escargot. You can sell them to people in the city. This gentleman didn't understand why his hayfield wasn't yielding well, then he happened to be late, and he harvested his hay at night. He was out at like 9 p.m. harvesting away, and it was dark. And the slugs were out, and he just picked them all up on the front of the plant. Sorry, the mower. So, I'm a guy that started to study slugs because farmers asked me to study slugs, and now farmers send me pictures of slugs on equipment. So here's a gentleman from near Effingham, Illinois, that was planting green. And so he's got all these slugs on the front of his planter. Presumably the slugs were up on the cover crop that he was driving through. Isn't that great? Slug City, now that's next. But let's think about slugs for a moment. I hope you don't suffer from slugs. If you do, you might not admit it in Nick's company, but I'm here for you if you have slug problems. Let's recognize what a slug is, though. What's a slug? It's not an insect. Whoever said that gets a gold star. Right? It's a mollusk. Wonderful. You guys are on it. I asked these questions in Pennsylvania. I go, thank you so much. It's a mollusk. It's more or less a snail without a shell. Right? It's more closely related to a squid or an octopus than it is to an insect. It's in a whole different phylum. Right? You guys remember the sentence that you learned for the Linnaean hierarchical organization? Mine was King Philip came over for good spaghetti. Yours must have been similar, right? Kingdom, phylum, someone's got one? Granulated sugar. King Philip needed granulated sugar. That's awesome. Love it. So, you know, kingdom, phylum, class, remember, does this sound familiar? These are in a different phylum. And you have arthropods, which are in Arthropoda. These are mollusks, they're in Mollusca. Okay? It's just a different group of animals. So you shouldn't expect an insecticide to kill a mollusk any more than you should expect a molluscicide to kill an insect. Okay? If you don't have any familiarity with slugs, I'll just provide a little bit of background. Slugs can damage virtually any crop that they want. They're a problem in the spring and in the fall. Okay? They love canola, which we're growing more and more of soybeans. Brassicas are their candy. They're really hard on soybeans because they feed off the cotyledons, the plants are dead. They'll eat alfalfa and small grains, and most people in Pennsylvania establish their alfalfa in the spring because the slug populations are too big in the fall. And then they love corn. Let me take that back. They'll eat a lot of corn. They don't love corn. It's like you feeding on Fritos for the next week. Like by the end of that, you're going to be protein starved and you're going to want a steak. Same idea. This is what slug damage looks like. So this is in southern Pennsylvania where we have some hills. And this kind of low-lying area that might lie a little wet, have thicker residue. That's where slugs hang out. That's where they thin the stand. Up front here, it's just a little bit more intermittent. Here's a soybean field in Lancaster County, so the southeastern part of the state after the third planting. So this gentleman tried to replant twice and still has these large gaps. Right, so it's just unacceptable. If anyone had this field up next to the road, you'd get made fun of at the coffee shop or something like that. But this is what happens when we merge these two worlds I just introduced you to. Insecticide use, preventative insecticide use, and slugs. Vertical axis here is number of slugs per trap over the corn growing season. The red line shows where we have a treated seed. So an insecticide coated on the seed. The blue line is an untreated seed, so no insecticide coated on the seed. The difference between the red line and the blue line is the difference in the number of slugs. And that difference is driven by predators. Okay? So where we have the blue line, we have more predators. They're eating more slugs. Where we have the red line, we have fewer predators because the insecticide is not killing slugs, it's killing the insects that can eat the slugs, and we get more slugs. Right? So this is from corn. So neonics and other insecticides, I'll show you in a moment, exacerbate slug populations. We did a detailed experiment in corn and soybeans to explore this phenomenon. I'm going to show you the soybean data. It was so wet that year that we had ducks in our cornfields. So we don't have those data. But it was a great year to do this experiment. So let me just walk you through this. And if you're into stats, the stats are on each figure. But this is a field experiment. And it worked awfully well. So here's the vertical axis is yield. Right? So it's just, the more the better. Soybean plants per acre, the more the better. As number of soybean plants per acre goes up, yield goes up. We'd be worried if that wasn't the case. But notice the color of the dots. In a bad, sluggy year, where we have the insecticides coated on the seed, the black dots, we have fewer plants per acre and we have lower yield compared to where we don't have insecticide coated on the seed. Right? Let's compare that soybean production to the slugs. So here on the vertical axis we have number of soybean plants per acre. The horizontal axis is the number of slugs per trap. To trap slugs, we use just white shingles. So we cut shingles into 1 foot by 1 foot sections, we throw them on the ground, and we just go out and we turn those shingles over and we count them. It's pretty straightforward. As the number of slugs per trap goes up, the number of soybean plants per acre comes down. And of course then, because of this figure, the yield would go down. But notice the color of the dots. Where we have insecticides coated on the seeds, right, we have more slugs and fewer plants per acre and thus less yield. Now let's bring those predators into play. So predators can help control slug populations, which is great. Vertical axis here is predation. The horizontal axis is number of slugs per trap, number of predators per trap. So these are things that like to eat slugs. To trap slug predators, we take a simple plastic cup, we put it into the ground, we sink it into what's called a pitfall trap, things bubble into it, we go out and count. It couldn't be any more low tech. Okay? Predation is a little bit more fancy. We take a waxworm caterpillar, which is a pest of beehives and whatnot, but you can buy them in bulk because people feed them to reptiles and whatnot. We stick a pin through the back of it, and we put that pin into the ground. And we wait for something to come and eat it. Right? We can do this with a caterpillar. If we did this with a deer, we'd be arrested. Right? But we have exemptions being entomologists. No one cares about insects. If you want me to stop doing this, just stop hitting the mosquitoes when they land on your arm, and we'll be good. Okay? So, this is predation. We do it with a caterpillar. We do it with a caterpillar and not a slug because a caterpillar has an exoskeleton. Remember, that's what an arthropod is. They have exoskeletons and jointed appendages. Remember all that? If we did this with a slug, they don't have an exoskeleton. They pull themselves off the pin. It's gross and fun all at the same time. You can try that at home. So anyway, now that you understand the figure, as slug predators go up, the amount of predation goes up. Okay? And that's a good thing because these things are eating slugs, or sorry, eating the caterpillars in this case. But again, notice the color of the dots. The insecticides are limiting the predators and the amount of predation that they do. So on average, we have fewer predators and less predation where the insecticides are being used. Then we tie this back to slugs. Last data slide that I'll show you. Vertical axis here is slugs, so that's just number of slugs per shingle. Horizontal axis is predation, so that same number over here that was measured with caterpillars. This figure tells us two things. So as predation goes up, the number of slugs per trap comes down. The two things it tells us is that these caterpillars that are being pinned to the ground are serving as reasonable proxies for slugs, okay? Because the slugs are going down at the same time. The second thing it shows us is that predators control slug populations. Okay, so the more predation we have, the fewer slugs we have, but insecticides are limiting them. By having insecticides coated on the seeds, the black dots, we have less predation and we have more slugs. So what we have here are those insecticides are disrupting biological control. It's not too surprising. Remember, put the insecticides out for other things, but our pest here happens to be a slug. So the insecticide is working against us. Okay. And believe it or not, so that these data were collected in Pennsylvania by one of my graduate students. These data are from Australia. This is a broadcast application of 2 insecticides. This is slug abundance over time. This purple line is the number of slugs where we're using chlorpyrifos, or lorsban, which is slowly being banned, but not quite yet. The green line and the green line's a control. The yellow line is a pyrethroid that's not as hard on insects. So it's the same phenomenon. I've been focusing on the insecticide coated on the seed, but our Australian friends have shown us that it doesn't matter where the insecticide comes from. They can be broadcast across the field. It's the same effect. If predators are being killed, then slugs have the upper hand. There were a couple comments today about decomposition. We want to have a good microbial community to help with decomposition. The first step in decomposition, in your crop fields, though, isn't a microbe. It's an arthropod. Okay? We've done some studies that have tested trying to answer this question: do insecticides limit decomposition? Well, the answer is yes, and it's got nothing to do with the identity of the insecticides. We had either landicide halithrine, which is warrior, pyrethroid, or we had a seed treatment. Both reduced the amount of decomposition by 10%, which means that in our fields, the residue that's in our field is sticking around longer, giving slugs more places to hide, while there's fewer predators out there. This phenomenon is driven by an arthropod, so that's a springtail. I would call it a clemelin. Those folks that have taken an entomology class would call it a clemelin. They're kind of fun little animals. They're called a springtail because they have something back here called a furcula that allows them to jump and spin and whatnot. You can say furcula in mixed companies and not get yelled at, because it's not a dirty word, furcula. You can say it too. But anyway, there are fewer springtails where we're using insecticides, because they're susceptible to insecticides. They're not insects, but they're hexapods, so they're 6-legged animals with exoskeletons. We just have fewer of those, which is why decomposition seems to go slower. When we have fewer collembolans, there's fewer things grazing on the residue. They're not moving fungus around enough, and then we have slower decomposition. Okay? So my bottom line for any pest, whether it's a slug or an insect, is manage for the pest that you have. Okay? If you don't know what pests that you have, I encourage you to find out. If you're just using insecticides blindly, you're probably not getting any return on that investment. Okay? So in Pennsylvania, right, slugs are our biggest problem. So if that's the case, preventative insecticides are making our pest populations worse, right, because they're not insects. We also have good evidence that they're limiting biological control or pest control generally. These types of products are also decreasing decomposition, whether it's applied to your seed or whether it's sprayed broadcast across the field. And these are just two of the functions that can happen kind of in your fields that we've measured. We haven't measured anything else, but I'm sure there's other things that are going on too that would take a finer tooth comb to study. Okay, so you're probably skeptical of all this. That's great. I welcome you to be skeptical of all this. But here's a little bit of evidence that shows that what I'm talking about can work. So for 14 years, we've had a project at Penn State called the Diversified Dairy Cropping Systems Project, where we're trying to grow all the food and fuel that an average-sized dairy farm needs. Okay? We're doing this by comparing two types of rotations. This is just a traditional corn-soybean rotation, what I understand is common around this part of the world. We're comparing that to longer rotations, 6-year rotations that include alfalfa, that include small grains, that include cover crops. Okay? In this rotation, we call that the high input simplified rotation. And this is kind of a diversified low input. From an insect and slug management perspective, we're doing two different things. My students and I scout these fields every week during the summer. And where we're using this corn-soybean, I think that would approximate what a lot of folks in Indiana are doing. So we're using BT seed for our corn. We're using seed treatments on both the corn and the soybeans. And then we're putting out pyrethroid shortly after planting with our post-emergence herbicide application. So we're getting 2 insecticide applications early season. The stuff coated on the seed and the broadcast that goes out with the herbicide. Okay? And the longer rotations, the lower input, higher diversity rotations, we're using IPM. So this means that my students and I scout these fields. If there's an insect pest population, we quantify it. If it's above an economic threshold, we spray an insecticide. Okay? It's that simple. To cut to the quick, our pest populations have been greater in the simplified rotation, over 14 years. Here are the first 6 years of the project. This shows the number of slug predators per trap. Year 1, 2, 3, 4, 5, and 6. The black dot shows the average number of predators in our low input fields. The gray dot shows the average predator populations are in our high input fields. So again, the high input fields is where we're using preventative insecticides. In the 4th year, we start to get more predators in the low input, where we're using IPM, and that stays true for the 5th year and the 6th year, and it's still held true for the 14th year last year. Okay? And because those predators are more abundant in those crops, in those plots, this is where we get this figure I already shared with you. The vertical axis there is the amount of slug damage in terms of the proportion of plants receiving slug damage, and that's the predator population. So the populations over here are from these plots that have more predators, less damage. The plots over here are from the simplified rotation, higher input, lower diversity. Okay? So that's the system that we want to see in most people's feed. Okay? All right, let's think about cover crops explicitly. So cover crops have been shown to help build predator populations. Not always, but most of the time. And most of the time where it works is where folks are using insecticides cautiously. Here's the results from a 3-year experiment. I can't figure out what I had before. So this is the number of ground beetles that I introduced earlier. They're also called carabid beetles. This is the amount of cover crop biomass. Again, this is from a 3-year experiment, which explains all the dots, all plots. But on average, we see more, where we see more cover crop biomass, we have higher levels of ground beetle activity. Right? And that's great. Those ground beetles then can work for us. And that's what we see in the right-hand figure. That's the amount of white grubs on the vertical axis, cover crop biomass on the horizontal axis. As cover crop biomass goes up, the number of white grubs comes down. That's fantastic. If we just plant cover crops and have white grubs come down, that's great. But that's not a direct effect of cover crops on white grubs. This is an influence of cover crops on ground beetles then controlling white grubs. So the white grubs are being eaten by the ground beetles, but the ground beetle populations are being driven by the cover crops. Okay? All right, so we know from our research that if you're embracing no-till, if you're embracing cover crops, you have a better chance of embracing natural enemies and them working for you. Here's an extreme example of cover crop use, and I'll give you the whole story. I have the time, so might as well. I flew all the way out here. So a good friend of mine named Lucas Criswell farms in Union County. It's about an hour east of where State College is. And this is the barley field that he was growing in the fall of 2009 when he asked me to come visit. I started my job in 2008. I had no idea what I was doing. I still don't, but that's a different conversation. So his barley field was disappearing. Right? And Lucas was super frustrated, and I was standing there like, I'm the new guy, I'm trying to help, I really don't know what I'm doing. What do you think? Lucas made the simple observation that if those slugs want to eat green tissue, the only option is to eat his barley plants. I was like, oh shit, Lucas, that's fantastic. It's a great observation, we can test that. Because I didn't have any ideas of my own. We went with it. Okay? So I got a little bit of money from the USDA, and we did a very simple experiment at Lucas's farm and our research farm. Here's our research farm. We did this both in corn and we did it in soybeans. This figure shows soybeans. On the side here, you can see a plot without something between the rows. Here we have something between the rows, and here's another plot without something between the rows. So all we did is we established in the spring cereal rye between rows of corn and soybeans. Very simple. We have a simple planter, a mechanical planter at the farm. We put the cereal rye seed in the fertilizer box. It came out a bit too thick. But we had these nice rows of cereal rye between our soybeans. And again, we did it in corn also. We needed it better in his farm. I just wasn't over there to take a picture of it right there. But the idea being that maybe having something between the row would distract the slugs. So Lucas's observation was, all they can eat is my barley if they want something green. And slugs are herbivores. They're plant feeders. They want to eat something green. So we gave them something else. So what was the effect? Well, the amount of damage to the corn plants or the soybean plants went down by about half. So here on the vertical axis, we have the amount of slug damage. We rate slug damage on a 0 to 4 scale. A 0 is 0, and a 2 is 50% of the material, of leaf material has been eaten. And this is where we have no rye between the rows, and this is where we have rye between the rows. So where we had rye between the row, we did what we expected. We diluted the amount of damage that the slugs were doing. That's great, right? So we showed that having something else out there could provide benefit. Unexpectedly, we found that we had triple the number of ground beetles where we had stuff between the rows. This is the number of ground beetles on the vertical axis where we had no rye between the row, where we had rye between the rows. Of course, we weren't using insecticide-coated seeds. We weren't putting a pyrethroid out after planting, and we tripled the number of ground beetles. These were small plots, so they likely came in from the surrounding area, right? They kind of walked in and knew there were some things they could eat. Right, so we decreased the amount of slug damage by about half, and we tripled the number of ground beetles. So what did Lucas do? He established he's a regular user of cover crops, so that fall, like before I even gave him the thumbs up, he said, all right, I'm going to leave a gap in my cereal rye cover crop. So he established this cereal rye the previous fall. This is him about to plant corn in the spring. And he had established his gaps in his cereal rye by just taping up every 2 holes on his drill. Okay? And now he's planting corn on 30-inch rows right under that cover crop. I don't know if that's a great idea. But it looks like planting green. So inadvertently, we stumbled into planting green. Right? And I'll get into planting green in a moment if you haven't heard that expression before. This was year 1. This is him year 2, planting corn. Didn't leave the gaps. All his neighbors thought he had lost his marbles. Right? This is how he does it now. Perhaps you've seen a planter like, here's a Kinsey planter with integrated rollers on the row units. So if we were standing here, the planter would be coming at us. Okay? And that's a little bit of an investment, those rollers. They're in, these particular models of rollers were invented by a Mennonite farmer in central Pennsylvania, and now he's licensed that to a larger company. I think it's based in Chicago. These are Dawn rollers now. And this is what it looks like when he plants. Okay, so here's his cereal rye, pretty tall. He waits for it to get tall because he wants the benefit of having that mat there. And then he rolls it, right? You can do this without rolling, but he rolls because he thinks he gets better cover, better planting conditions, and that biomass persists longer. And there are clear advantages to these swaths of residue. The first of which is you don't need as much herbicide. Okay? Because the weeds are being smothered by the presence, so they can't grow through it. There's two slug control benefits. One is that we found that, so one key detail, that 1 to 7 days after you do this, you come back with an herbicide application that includes glyphosate. That glyphosate is going to kill your cereal rye slowly over the course of 2 weeks. As it dies slowly, it's going to release free protein. Slugs are protein hungry. Slugs like to feed on this dying cereal rye more than they like to feed on the corn or the soybeans coming up between the rows. Right, so that's the second benefit. 1, fewer herbicides are necessary. 2, the slugs like to feed on this mat more than the corn or the soybeans. And the third is that is a fantastic habitat for those natural animals. Okay. So Lucas was able to drop his insecticides, decrease his herbicide costs. He's saving, when he started this, he was saving about $9,000 a year just by planting this way. And to be frank, we didn't understand how the system worked. We thought we knew, we didn't. So I worked with some colleagues, got a little bit of money. Then we started to do work on Lucas's farm and 3 other farms in central Pennsylvania. The data here are from those 3 farms combined. So we found, so planting green, I'm going too fast. Planting green is a tactic that farmers have used for a while. Typically the farmers that I run across that have done it want to plant cover crops, but they're always late. Like they don't burn it down fast enough because they've been doing other things, and then they end up, well, today's the day to plant, conditions are good, I'm just going to plant right in my cover crop. And if you go to graduate school or for entomology, or you've had an entomology class, you learn one thing, if you learn anything, avoid the green bridge. Have you heard that expression? Avoid the green bridge. This is doing the exact opposite of avoiding the green bridge. This is embracing the green bridge. Okay? That green bridge thing was taught to me a little while ago. I don't know if anyone really does that. But here we are. So now we're working on commercial farms. Right? This isn't our research farm. These are full-size fields. And this is planting green plus RPM. So we convinced these growers to use untreated seed, drop the insecticide from their herbicide application. And we had 3 treatments in each farm. We had bare, so no cover crop. We had brown, which is just a traditionally managed cover crop. So the cover crop is brown at planting, so we killed it 2 or 3 weeks earlier. And then we have planting green. And in June, July, and August, we have the fewest number of slugs where we're planting green compared to, particularly compared to no cover crop. Like cover crop, no cover crop consistently has more slugs anywhere else. And when you take the insecticides into account, this is the pattern we see. The vertical axis here is the average number of slugs planting bare, so no cover crop, planting brown, cover crop brown at planting or planting green, cover crop green at planting. Where we have the most slugs, we're using an insecticide-treated seed and no cover crop. Where we have the fewest slugs, we're planting green with no insecticide because we're embracing the predator. And this is a figure just showing the yield. Vertical axis is yield over those same 3 treatments. When we did this experiment, there was a little bit of a yield drag from planting green, in part because the farmers were still getting used to it. Lucas has assured me that yield drag has gone away, and actually he's thriving. Has the biggest yield he's ever had planting it this way. Now I'll acknowledge this is planting ugly, right? This is farming ugly. Steve, you said you had a t-shirt that said farming ugly or something like that? This is farming ugly, so you really want to try this, embrace that ugliness, right? It is higher management. But when you have slugs, this provides a clear benefit. Okay? It's just a good example of using cover crops in a positive way to limit pest population. If you happen to grow a crimson clover cover crop, call it planting pink. Fine. This gentleman is doing this in western Maryland without the rollers on his planting. Right? That's him planting corn. Beautiful. Right? And then when I go to a field day, I don't just go with my egg-headed self, ivory tower guy. No, I tell Lucas to join me. I buy him lunch. Come on along. And then standing next to a field where he's had success, farmers, NRCS folks, conservation district people, they believe him before they believe me. Right? So this provides a little bit of authenticity, a little bit more credibility when I bring him along. And he can talk about it from a farming perspective. I'm invoking that today because there wasn't a seat on the playing field. We have about 33% of our no-till farmers in Pennsylvania that are planting green. And I missold. We have an organization called the Pennsylvania No-Till Alliance. Of that membership, 33% are planting green for slugs. So, those are my take-home messages. My main point, that's just about it, right? Yeah, so my main point is for these take-home messages. So, no-till and cover crops build diversity and can improve pest control, but you gotta let it happen, right? Just using a typical insecticide program is gonna work against that. That diversity can improve crop production, but integrated pest management is the key to protecting that diversity. But pairing IPM with cover crops can really make things happen. Now, I'll say as a last thing before I take a question, I welcome extreme skepticism about any of this. That won't work in Indiana, fine. But you have the same capacity that Neil pointed out. You can test this, right? You can use an untreated seed if you can find one. You can use an untreated seed, start using cover crops, and see what happens. But my bet would be that you'll be successful. If you want to talk about planting green, I'm happy to do that. But the best way to start planting green is finding someone who's already doing it and getting coached by them. All of the members of the Pennsylvania No-Till Alliance board members are online. You can call them. You can call Lucas. You just Google his name and Pennsylvania No-Till Alliance. They'll be happy to talk to you. Okay, with that, I'll stop giving caveats and I'll answer any questions you might have. Yes, ma'am.
So on your spider plot, why would the decomposer diversity and density be higher with the moderate insecticide? I think it was the yellow line.
Yeah, that's a fair question. So, it's a good observation. So, these are field data. They're not as clean as we would like. So that's why I focused on the none and the high. Intermediate gets a little bit messy. So people see that intermediate like, well, maybe a little insecticides could be strong. And I don't have the type of granular information to determine why that is. That's why I kind of focused on the extremes. Okay. Good observation. Other questions?
I've heard that the use of neonicotinoids and their carryover is partly responsible for the decline in bee populations. Do you know anything about that?
Yeah, so folks at Purdue have studied that more than me, so your invitee last year, Christian Krumke, has been part of that work. The non-target effects of neonics are fairly clear. They limit good insect populations, including pollinators. There are other things going on too. There's varroa mite, and there's less kind of foraging habitats, there's fewer flowers around. So all these things are kind of providing negative influence on pollinator populations, but there's no doubt that neonics and other insecticides are playing a role. The unfortunate piece of this puzzle is that neonics have gotten so much attention that kind of lets like the pyrethroids off it takes a little emphasis off of them. But a pyrethroid sprayed on a windy day that's going to land on plants downwind is going to have a similar effect to neonics. The challenge for neonics is that they're water soluble. If you have any pitch to your land, they're going to run off. And if there are trees over there, they're going to be taken up by those trees. And if bees visit those trees, and like maples or celtis or something like that, then they can be exposed to the insecticides through the plants. So that's part of the role. And so Christian studied dandelions and found that the dandelions had greater amounts of neonics than other ones, just as a sentinel plant. That's really common along the field edges. But there's no doubt that it's difficult to say that the neonics are responsible for, say, 25% of the decrease or 75% of the decrease. They're in the mix and they're a significant factor. A bigger concern, paper came out at University of Illinois in 2020, has shown that the neonics are directly causing bird populations to go down. And this has been well documented. I see fewer birds in Pennsylvania these days. I don't know if that's all attributable to neonics. It's probably not, because of climate change and habitat limitations, the same thing. But there is no doubt there's a statistical relationship between that, the amount of neonics being used in every county in this country and the bird populations.
I have heard too lower numbers of, I call them fireflies.
Yeah, that just came out.
I've heard people talking about that.
Yeah, there was a science paper that came out like 2 weeks ago showing negative influence, showed the influence of climate change, pesticides, habitat loss on butterflies. And so again, neonics are part of that equation. It's difficult to separate them out. Yeah, and so I've had fellow entomologists yell at me for telling this stuff to farmers. And I've had farmers yell at me for telling this to them. Right? Because they're like, well, you shouldn't be talking about that. That's a bad thing. We're going to get these things banned or regulated. I don't want them banned or regulated. I want them to be tools in the toolbox. But in current use patterns, they're far overused. Greatly overused. So you can easily get untreated soybeans in Indiana. If you're not using them, I encourage you to try. That is the easiest first step. It's far more difficult to get untreated corn. Some of your big seed companies, I won't name any of them, but some of you guys have hats on it by this company in here today. They are just more or less refusing to provide untreated seed. But the writing's on the wall. There's going to be something changing. New York banned these chemicals by 2029, just last summer. So I don't know if that's going to be a sweeping regulation across the country. With the current administration, who's not really into regulation, it seems unlikely, but somewhere down the road, it's going to happen. Just too much environmental kind of unintended consequences. So what I'm trying to do is encourage farmers to use IPM as a way to moderate their use. So should they ever do go away, then you won't be probably against it. Other questions you have for me? I did fly all the way to Indiana. Please.
Yeah, you indicated that you did use the spot application of pesticide where you went required. What pesticide did you use?
Oh, great question. So in that in that experiment where we had white grubs, we were above economic threshold for white grubs. We used force. We have a planter that can accommodate insecticides in the boxes. We used force. Remarkably, the force wasn't as good as the predators. In that bigger project that's been going on for 14 years, we have gotten armyworm outbreaks, we've gotten black cutworm outbreaks. When we do that, of course we put an insecticide out. Our goal is to try to limit those populations. We've used Warrior for potato leafhopper in that system also, because we have alfalfa in the more diverse rotations. When we have a caterpillar outbreak, though, we have an opportunity to use a very specialized insecticide that only kills caterpillars. So we use something with an active ingredient called methoxyfenicide. The active ingredient only kills caterpillars, and it kills caterpillars when they molt from one stage to the next. I think the trade name of the compound made by DuPont is called Belt. But you can get a generic version, and it's called, it's not called Aldemit, I can't remember. But there's a generic version of methoxyfenicide that you can kill used just to kill caterpillars. And that's the thing, so a lot of folks hear my message and like, that guy, he's anti-insecticide. Not anti-insecticide, I want insecticides to be available, but using when they're necessary is kind of the key. So if you're just using pyrethroid after planting a treated seed, but you have no sense if that's providing a return on your investment, I would encourage you to figure that out, because that stuff's not inexpensive, right? And just stewarding it a little bit better will help everybody have access to it for a whole lot longer. Thanks for the question, sir. Other questions? Oh, yes, ma'am.
Do you do any research specifically on organic acres?
I have done research on organic acres, and I have a good colleague at Penn State who is an organic field crops entomologist, just more or less my counterpart in the field crops world. Yes, so what will be your question within that?
Was the data similar, or do you simply have to use a different pesticide?
No, that's the amazing thing about organic field crops is, at least in our hands, we can't get enough pests to need to do anything about it. right? All of that research, not all, but all the research I've done in organic systems has been on our own research farms, so those are smaller fields, there's more diversity around, and I can't get insect pests to matter, right, which is frustrating. But the natural enemies are part of that equation. My colleague named Mary Barbacek has done on-farm research with her large acreage corn and soybeans folks. They just don't get pest populations that amount to much. They're never on the economic threshold, so they never need to spray anything. If they did need to spray something, it would probably be uneconomical because the cost of those materials and the number of acres just don't add up. Okay? All right, anyone else? All right, yes?
You mentioned the tillage system, we saw more wireworm, talked about the effectiveness of the seed treatment. You saw more in the tillage system. Do you have a reason for that? Or?
Yeah, so we've done research that shows that insect pests are more abundant in tilled systems. And to get more detail there, we find more insect pests in tilled systems, but those insect pests are pests of the foliage, so the leaf eaters. In no-till systems, the reason that there are fewer pests is because of the predators. But if there is a pest, it tends to be a below-ground pest that these predators can take care of. So it's not a guarantee that a no-till system is going to have no pests, right? But you have more predators there to help. Our results also made sense because we had fewer soil-borne pests where we're using tillage, and that makes good sense because tillage is disrupting those communities every time you take a pass at the tillage. So, but it seems to be driven by the predators. There's just fewer predators where you're using tillage because most of those predators have some portion of their life cycle below ground. It's not always the case, but it's often the case. Okay? Great. Thank you for the question. Appreciate me. Please.
How often do you recommend scouting?
That's a great question. So this is a question that you'll get a bunch of different answers on. But when I talk to growers about this, it's usually every 10 days.
And let's say you have a 100-acre field, how much of that field should be scouted?
Right, so you want to be able to do, typically we talk about a W shape through the field, and you talk about covering as much of that field as practical. So you know your fields better than me. Maybe the part near the woods is a little bit more shaded. It might be more prone to pests or something, maybe more slugs over there. But we recommend just scouting as much of the field as you can do with the time that you have. Right, so this is one of the key parts of IPM is that the hope is, and research has borne this out, that the money you save on not using insecticides or any other pesticide, depending on the pest you're talking about, you'll be able to put into some other resource. And if that's manpower to walk that field more regularly, that's manpower to walk the field. Great, thanks. Good question. Okay, you want to, yeah, please.
Have you looked at bricks levels in the plants and how that affects the insect?
We have not looked at Brix levels in plants to see how that influences the insects in our systems. Colleagues have, most of the information on Brix comes from outside university folks, and that says the higher the Brix level in plants, the lower the insect damage. I don't really know how to assess that. I've never seen those data. People talk about it on podcasts. I've heard it. People also say if they put sugar in the row, that they don't have as many pest problems because they're feeding microbes, and those microbes then support the whole food web. Research at Penn State has not seen the same effect at that, but I don't discount those anecdotes from practice, experienced farmers. I haven't seen it, so I can't really comment on it. I can maybe express some skepticism, but I can't tell them that they're wrong. Okay? Yes, sir?
Have you seen any differences with planting dates or
In terms of
tests? I mean, early versus late or?
And then the benefit of the insecticides? Yes, great question. Yes, so the earlier you plant, the more likely it is that you're going to gain a benefit from the insecticide or the fungicide on your seed. The challenge there is that if you, let's say you use a fully treated seed and when you plant like you always do, and you don't see a pest outbreak, you're likely to attribute that to the insecticide doing what you think it should be doing, which is limiting the pest population. When it comes to these things that are being targeted by the seed treatments, black cutworm, seed corn maggot, wireworm,
given their kind of general abundance in the farming landscape, a simpler explanation is that the insect pests weren't there. So yes, the answer to your question is yes, there's more of an advantage the earlier you go, and there's less but the earlier you go, the less likely it is that those insect pests are active because they're insects and they're only going to be active if it's, say, 50 degrees or warmer. So there's a little conflict in what I just told you. So I think that conflict is resolved a bit by the fungicidal piece having more value than the insecticidal piece. But you talk to your seed company, you can't go a la carte like that and say, I want this but not that. They want to sell you a package these days, right? And just to build on that idea, so thank you for your question, sir, and it always prompts, well, how do you get untreated seed if you're interested? In Pennsylvania, I point growers to the local seed sellers, the local seed producers even. So the large national companies that would, if they were in this room, they'd be yelling at me and they'd have bulging neck pain, you're full of crap, which is fine. But the local companies in Pennsylvania, they like to sponsor our extension events because they can get more customers, just to try it. Okay? Sir, was there a question in the back?
Yeah, the question was, have you done comparisons of research between seeding predators versus using insecticides?
Yeah, well, what do you mean by seeding predators, sir?
That you're actually putting additional predators into the field, not just...
Yeah, you can do that in your backyard. Like you can go to Gardens Alive from Cincinnati, Ohio, and you can buy lady beetles or praying mantises or syrphid flies or something like that, or you also buy lacewings. I don't think anyone's growing ground beetles to sell. I had one colleague who used to be in South Dakota that was selling Monsanto one ground beetle for $1. If I could do that and sell them to the world, I would. But raising a predator is hard, and not many companies have focused on. I don't know any companies focused on ground beetles.
I've seen some done with ladybugs.
Yeah. Exactly right. Yeah, you can do that. You can also buy little bitty wasps for growing sweet corn to take out your European corn borer eggs, that type of thing. That has great value and that has effectiveness. But I've never seen it for ground beetles, and I don't expect it to come anytime soon just because it may neck to grow them. So we can keep them, and we feed them in the lab. So we'll go outside and we'll collect them, and we'll bring them into our lab, and we can keep them alive maybe 8 months, maybe 10 months by feeding them wet cat food. So if anyone can take that idea and just run with it and come with a company, I'll be happy to be an advisor on your board. Any other questions that we've shaken loose here? Don't be shy. Please.
So you said in the organic systems that you have so few predators, you can't justify.
So few pests.
So few pests. So what do you attribute that lack of pests to? Because they're doing the tillage, they may be doing the rotation versus the no-till cover crop. What makes that difference?
So in organic systems, there's more disturbance, but there's more diversity. So there's more weeds, there's more crop, what we call architectural diversity. So in organic systems, the reason there's not many pests is because that diversity overwhelms that occasional disturbance from tillage. That's pretty well established. And those fields tend to be smaller, they're more easily colonized, they're often grown in proximity to natural areas because organic farms tend to be greater, more diversified generally. So it's that diversity of things that attracts the diversity of natural enemies that then limits the herbivores in those fields. Does that make sense? Yeah, that's pretty sure that's a solid answer. Anything more? All right, going once. Well, I greatly appreciate your patience and staying with me for the end of the day. I appreciate your attention and great questions. Thank you for having me to Indiana.